Now I will discuss we will try to find the solution of the problem from the survey book, chapter 25, problem number 2. Problem number 1, uh, solution link is given in the description. So let's start. So the question number 2 is how much work is done? Okay, how much work done in moving Avogadro numbers of electron from initial point where the initial potential is 9 volt to the point where potential is minus 5 volt. How we will solve it? Let's start. How much work done by the we have to calculate the work. Okay, solution. So we have to calculate the work. What how much work will be done, and what is given Avogadro number of electron. Total number of electrons are equal to Avogadro number, so the charge will be equal to Q multiplied by Na. Q uh, okay and the potential sorry, okay, so where the electric potential is 9 volt to Avogadro number initial point where electron potential, how much was done in moving Avogadro number from the initial point where the electron potential is 9 volt to the point where the potential is negative 5 volt. Okay. Uh, Charge on electron, we know that that is minus 1.10, 1.6 10 raised to power minus 19. Avogadro number is equal to, and Avogadro number is we know that 6.02 10 raised to power 23. Okay. So, as we know that what is the work, we have to find the work potential. Here potential difference is also given. Initial potential phi is 9 volt. Final potential and final potential is minus 5 volt. Okay. So this implies that delta phi will be equal to change in, that is phi f minus phi I. So delta phi will be equal to minus 5 volt minus 9 volt. That will be equal to uh, minus uh, minus 14 volt. Okay. So that will be the potential. Okay. So what will be the work? Work, as we know that work will be equal to, as we know that work always stored in the form of the potential energy. Okay. So work will be equal to it always stored in the form, when we do work, it will be always stored, that is always equal to negative of potential energy. But in this problem, work is done in moving Avogadro number from electron from electric potential 9 volt, high potential to low potential, and electron always accelerate toward the from electron always from high to electron because the final potential must be a far in, as I have already discussed in the problem number 1. The work will be this work will be equal to the q delta phi, and q is given this, so this mean that will be equal to minus 1.6 10 is power minus 19, 6.02 10 23, and minus 14. So result will be equal to 1.3 when we calculate it, and that will be equal to 1.10, 1.3 10 raised to power 6. And so you may say that that will be a 1.3, uh, uh, sorry, mega joule. So that will be answer. This will be your required result.